chicken plow. You tell me what else is on the menu, please, sir, for today.
This is a Hollinger BC08 guitar amplifier. And next to it is the Altoids Tube Amp for size comparison. This is a very small amplifier. You see? That's Altoids can. The power switch is on the back. The speaker is halfway exposed. There's this panel here that blocks the transformer there. On the front it's got your CD tape input that no one ever uses because they always sound terrible. And the guitar input. 1/4-inch headphone jack, 2 tone controls, and a volume and overdrive switch. Measures 9 by 9.5 inches in the front and 5 inches this way. It doesn't say so on here, but this is a 10-watt amplifier.
No user service parts inside.
Behind that little panel you see the speaker wires that were soldered, and this power transformer that says right on the bottom of it that it puts out 13 volts times 2. So I'm going to pull the head out and see what's in there. There it is. There's the amp. It uses a TDA 2030 IC back here for the power amplifier, and this board that don't look bad. Man, it looks better than the board that was in the third act back when it was the first act. I wasn't expecting to see this. There's a NTC thermistor right there. The overdrive switch. There's nothing special about this. There's a 4558 op amp. I don't see any LEDs on here though. But I do see 2 Zener diodes that are pointed in opposite directions. That's where the overdrive comes from, and it isn't like crazy. This amp's pretty lame like this. We're gonna change a couple things to make it cooler. Starting with this, that's better. So now that's taken care of. Let's remove all the parts out of this that make it a shitty amplifier. So I've taken the entire board out of it, but I've left the power transformer and the power switch, but nothing else. I'm gonna move this little panel down to the bottom because look at it. Why the hell did they have it where it was? That was stupid. This looks way better. Plus, we're gonna want this open. I've got a pair of Amperex tubes here, a 12AX7 and a 12BH7. So we're going to scratch make an amplifier circuit using these 2 tubes here, and we're going to use it to turn this little 10-watt shitty practice amp into a totally awesome tiny little tube amp. What do you think about it? That transformer is way too small. So I'm going to use these 2 to make the high voltage and the 12-volt filament voltage and stuff. These are all the components. In here we got 3 of these tie strips over here where the transformers are, and we got 2 of these over here, and that's the space we have to work with. The audio output transformer is going to go right there and be held down by a zip tie, and there's not really any room to spare. There's lots of wires sticking out. I get to deal with this tangled mess. That's much better. Well, there's that, if you want to scrutinize that. And there's the schematic. This is the layout diagram. So there you go. Here is the datasheet example schematic of a deflection amplifier. Basically, if you just replaced this side over here with a speaker, it's just an audio amplifier with a variable bias right here. It says right here, 18,000 ohms. Minimum primary impedance. Harp on that a little bit later. There's the power supply section soldered together. It's 12 volts DC filaments, a little rectifier there, and a capacitor, and then, you know, the 300 and something volts DC and the other capacitor. The transformer fits like that, so that's pretty cool. The pots can't be removed with the transformer in place. So next I get to install the wires on the pots and orange juice casserole and potato peels. Put the wires on these terminal strips and stuff. Now that stuff's done, the transformer and all the components and stuff won't be in the way of putting the wires and pots in later. You know, when this started, I thought there was going to be some empty space in here, but it looks like there's not. Now I've got the audio output transformer mounted in place and wired in, and power supply's not goofy enough. We got to make it worse. So here's the deal. I got the power supply all done, and I was testing it without the amplifier wired in, make sure that the voltages were good, and they looked fine. Decided that I would hook the breadboard up to it just to make sure that this power supply that I haven't yet actually tested to run the amp is going to work. So I've been running it off of the Altoids Tube Amp power supply over here up until now. Well, guess what voltage it sits at when the tubes start conducting? It says 127 volts. It's supposed to be over 300 over there. So it's really thin and shitty sounding with that power supply. So I've got the Altoids Tube Amp power supply over here, and I just... Now she sits at 300 and it sounds much better. Well, that means that little Sansui power supply transformer back there from the 1971 tuner that I took it out of is not going to work for this. But it's already there, and look at it, it's all like installed and stuff, so I'm not taking it out, and I'm not making the amp where it can't use it if it's there. And I'm also going to install a new power transformer to solve this whole voltage sag issue. And because of the fact that it will have two step-up transformers that generate different sound profiles, now you can switch between high and low power modes for different sounds. That's how the wiring turned out. It's much more complicated. So having the switch in the up position will use an external transformer here instead of that old piece of shit. But of course, if you put it in the down position, it'll work like it did before we put the little switch in, and it'll have the thin, fuzzy sound if you want that. Sitting here wiring this thing. I've got it about half put together with the, you know, the amp circuit and stuff. Tornado outbreak tonight, so that's pretty cool. Timex just hit the 10,000 miles since we fixed it mark. I got the map here next to me. We got a tornado outbreak going on, and we're gonna go and see if we can see a tornado. Because we're real big fans of his, aren't we, Randy? That's what I'm talking about right there. Like, that was pretty cool. So let's get on with this. Wiring completed, I think. That's how it turned out looking. So now I get to test it and find out whether I screwed anything up. And it will squeal if you turn the gain up all the way. I was wondering if that would happen. On the breadboard, there's a mega ohm resistor here in series with the wiper of the gain pot to prevent squealing. But I decided not to include that in the actual circuit, just in case it wasn't necessary. Turns out it is. Now I have a 1 meg resistor hidden in there. So on the clean channel, good treble response and all that. But when you unplug from it, there's a little bit of a hum. That's annoying. Overdriven channel. Yeah, that works. But just like before, but a bass. I'm just gonna pluck this string and the lower the frequency, the worse. So the input stage is broken. If I plug the bass into the clean channel, everything's fine. So both of the power levels work fine and everything if you run it into the clean channel, but you just don't get that easier overdrive that I want out of the overdriven channel. The 12BH7 input stage is very, very unhappy. We're going to need to probably do something with that. Looking at the voltage to the input stage, it's 221 volts. I figured on 150 volts. That's quite a bit higher than that, so I think my first move is going to be increasing the value of that dropping resistor to get a lower voltage there. Melted that wire. Now there's 300K there, and it's going to sit at some voltage lower than orange. So I've got a 1 mega ohm there in series with the wiper of the volume pot now to match the one over on the gain pot. And with the 300K resistor there for the second filter, we'll run 114 volts. You can hear that there's a hum going on, but that's maxed out, and I'm good with it. If we turn it to low power, the input stage starts to sit around 60 volts. Maxed out, plugged into the overdriven channel, it does have a bit more of a noise floor. It also sounds better. Distortion on any of the power levels, so problem solved. She's ready to go. Not really, because that 1 mega ohm resistor forms a low pass filter and completely kills all treble. So replace it with a 470K because it kills less treble and it's acceptable. So that's nice. That wire that's all melted now looks like shit. That looks better. It needs to look good because, you know, no one's ever going to see it. The hum is a squeal. Look at all that. This is known as tube squeal. I'm not putting a signal into this amp at all. This is just the sound it's making on its own. What I'm doing here is I'm playing around in this one area of the volume pot that seems to cause it to do weird stuff. So, as you can see, the buzzing is not just filter hum. Now, this didn't happen on the breadboard, and I've substituted in giant capacitors and saw no difference. Also, the frequency is not always 120. That's the third harmonic of the line frequency. That didn't come from the rectifier. And that is parasitic oscillation in the tubes. Varying the gain is actually able to vary the frequency. So you can calm down about the filter capacitors. The problem is not the filter capacitors, it's everything else. The amp is fucked. However, we are going to finalize it in its current condition because hail Satan. And we just did the test with the oscilloscope and the function generator to find out the power output, and the RMS voltage to the speaker at clipping at all frequencies is roundabouts 1 volt, giving us a whopping 1/4 of a watt. That's not really a surprise. That's what we got out of the last few orange juice machine triode based preamp amplifiers, or whatever you want to call these things that we're building. It's Squeal Cannon on EN1. The amplifier puts out exactly 1/4 of a watt clean. So we have reduced the power output by 40 times. The amp also now squeals and has an audible hum under some conditions. And the overdrive channel is very muffled, has poor frequency response, has unpleasant sounding distortion under about half of the conditions that it could encounter. The clean channel has about half as much overdrive as you would want out of an overdrive channel. And it's got tubes in it. So, factoring in all factors, we have clearly improved this amplifier. It weighs just over 4 kilograms, 9 pounds 3 ounces in freedom units, and it consumes about 20 watts sitting there doing nothing. You get to talk about what we did right. I have in front of me the data sheet for 12BH7. It shows all those maths that some people don't like to talk about and other people like to talk about too much. So, Class A amplifier, DC voltage, 300 volts. That's exactly what we're running it on in high power. 3.5 watts. We have it biased at 3 watts. Maximum grid resistance on a cathode bias, 1 million ohms. We already looked at the example schematic that they used that was supplying it with 350 volts for a deflection amplifier. So this is the DC load line here, the diagonal straight line for 350 volt supply voltage. Because we're actually running at 300, we get to go from here to here, and that shifts the whole line down a little bit. Otherwise it's the same. You can see that the dot is below the little maximum dissipation line, so it's okay to sit there like that. This oval down here is the inductive load line. So because the speaker is inductive and it's going through a transformer, it has inductive reactance, not resistance. Resistance draws a nice perfect straight line like this. That's why the DC load line is a straight line. But because the load is inductive in AC, it draws an oval. The shaded area down here is the cutoff clipping. And this little shaded area over here is the grid current clipping. And it looks like there's a little bit more of this one than this one. Meaning, good, I guess. The harmonic distortion because of how close together the lines get over here compared to over here. That makes a ton of second order harmonic. And it's going to have ugly sounding clipping and blocking distortion caused by these. Now if you want to check out Deep Blue Harp's video series on inductive load lines, particularly parts 3 and 4, which focus on the math involved in drawing this oval and explain exactly why it's there. And if you're not an engineer, skip those 2 videos and instead watch videos 1, 2, and 5. And that'll tell you exactly what you want to know about this, and after you watched that, you can write all of your opinions in the comment section in great detail. Little thing that I showed for 1 second earlier in the video is the impedances chart graph pictograph machine. The tubes are represented as circles. The actual resistances of the resistors are marked here, and the impedance of the input and output of each tube are calculated and written down here for the purposes of determining this ratio, which tells you how much of your signal gets lost in translation between stages. It also tells you what size capacitors you're going to need for the coupling. Some of the numbers on this paper are incorrect. This schematic doesn't include any of those resistors that we added haphazardly. You shouldn't build this amp, or this one for that matter, because they're made completely out of random parts pulled from random things. The speaker in this amp is a 4 ohm speaker, but it measures 3.5 ohms on an ohm meter. The impedance is 4 ohms because of the added 0.5 ohms of inductive reactance that is imposed on an AC signal that passes through the voice coil. Its DC resistance is 3.5 ohms and its impedance is 4 ohms. That means its reactance is 0.5 ohms. This transformer right here, which is the same one used in the Altoids Tube Amp and the TATTAS, has a primary resistance of 3,500 ohms. That does not mean that it has a 3,500 ohm impedance. Transformer takes in 277 volts and outputs 16.3. That gives us a turn ratio of 17 to 1. That's the impedance ratio. You multiply whatever impedance your speaker has by that number to get the primary reactance of the transformer. In this case, we have a 4 ohm speaker. That gives us 1192 ohms. But we measured this on an ohm meter and we saw 3500 ohms of resistance. That's much more notable than the 200 or 300 that you generally see on some real output transformer. Meaning in that configuration with a 17 to 1 turn ratio, the primary impedance of this particular transformer as seen by the tube is 4692 ohms, not 1192 ohms. Using the same math in the same way as before, on the actual transformer that we really used in this amp, we get a primary impedance of almost 25.5 kilo ohms. And even if you don't want to hear it about the 7,000 ohms of resistance being an actual component of the impedance, it's still 18,496 if you want to, and that's still above the 18,000 ohms minimum primary impedance of the transformer. So we did not give the tube the wrong impedance. There you go, we have successfully harped on impedance. Explanation was that you can make an educated, hateful comment. This amp is not very good by the standards of most people in the world. However, we are particularly fond of it. We love the sound of the squealing. We're disappointed that the third act wasn't able to squeal. And this one accidentally squeals and the third act accidentally doesn't squeal, so clearly we don't know what we're doing. The main reason this amp is so lousy is because it uses a triode for the output tube. That is also the reason that it's so quiet and only puts out 1/4 of a watt. The whole goal of this amplifier was to make a real-life tube amplifier that you can play guitar through with good sounding overdrive without it being very loud. We have successfully done that with this amplifier thanks to the 12BH7 and its measly little 0.25 watts of power output. The amplifier will play at a reasonable volume with full distortion, and it is actually sounding good as long as you like the sound of it. Now, if you don't like the sound of it, then don't build it. If you do like the sound of it,
you're a racist donkey mouth. You're a very large woman. Very disgusting. Donkey show. Mustache. Disgusting. You're a slob.
You could take a donkey by the ear and hold on tight and ride across the range and look really rather romantic. Where you hold on to the ear and you're riding bareback.
Never been to a donkey show, Bill.
we are, in fact, going to make more videos about the Altoids Tube Amp. There's going to be 2 more amplifiers, a power supply, a speaker, and some other stuff that I haven't come up with yet. 500 people have subscribed while watching that video so far at the time of this recording. So it stands to reason that at least one of them made it to the end of this video and was wondering about that. So hopefully that answered your questions.